Hey, and welcome everyone to the 2024 October Fellowship Call. This is the monthly call where the core developers of the Polkadot runtime come together to discuss the latest developments, new requests for comments, new requests for proposals, discussing the different epics, what's going on in Jam, what's going on in Plaza, all the big things. And we have members from all ranks of the fellowship here today. And as always, we want to start with the new members. So I know that we have at least one new member here that has not been on the call here before, and I think it's you, James. Is this right?
Correct. So thank you. Happy to be here. And people that don't know me, I'm a PBA alum from the Berkeley cohort and a senior ambassador based in Miami, Florida. Thanks.
Awesome. Great to have you on. Yeah, is there any other new members that have not been on this call before?
Yeah, me. I missed the last one. I was just introduced before the last one. So I'm George. I've been working at Parity for for over a year. Just got inducted last month, and looking forward to participating in these calls and yeah, making a difference here.
Awesome, great to have you. Yeah, today I sneaked my way into the Parity in Lisbon. And it's very exciting to be here. Polkadot Blockchain Academy X is filming here new materials to get more Polkadot SDK people and substrate developers and blockchain developers on board. So yeah, I hope we can make a difference here. For the format today, we turned it a little bit on its head today. So we tried to get I would say, the most energetic things on the top of the call. And the idea, as always, is to be valuable for members of the fellowship to get updated on everything that's going on in, let's say, the other parts of the fellowship, but also for everyone listening in, trying to understand more about how Polkadot development is working to get a better grasp on the situation. And yeah, I want to start today. So basically how I was thinking about going on today is talk a little bit about the latest release. Then I'm going to throw this question into the room of what is everyone working on right now. I think this created a lot of interesting energy and discussions last time. And then we go into more structured approach where we talk about Plaza, we talk about Jam, and then we talk about the big epics that we typically talk about, like bridges, async backing core time, elastic scaling. And we also have a few RFCs that members of the fellowship reported in. If for some reason you have any time constraints and you want to discuss them earlier, let me know, maybe in the chat. And otherwise, we will just go about the path like I just described it. And to make sure everyone has this point of this, has the agenda, I'm going to post it in chat again. And I see it was already posted before. Okay, so let's look into the latest runtime release. This is the release that was just put on whitelisted caller and is basically going through. And this is runtime 1.3.3. So this is the latest minor release of Polkadot. And I wrote down some of the interesting things that I see here. So there's quite a few items here. What I found to be interesting is the PR allowed signed origins to send arbitrary XCMs from some system chains. So it basically means that the users can now submit XCM. And yeah, I think this is going to be interesting. I saw that the POP team already was working, but maybe this is different. So maybe to clarify this a little bit, does it allow a user to, for example, on Asset Hubs, send an XCM and then it does something on another chain like Relay chain or any other chain? Is it like this? I should always call a person that is onto that, right? Okay, then
Adrian, you want to say something?
Hi, Basti.
Adrian? Yeah, hi. I thought Adrian wanted to say, but he's muted. And Adrian?
Hey, okay. Yeah, sorry.
You just joined. Okay, no. Maybe you'll be like ask again, Tommy. But Adrian can answer that.
Okay. Yeah, so Adrian, maybe you noticed I saw on the latest release, there is this PR allows signed origins to send arbitrary XCMs from some system chains.
Yeah, it's not in the next release. It's just the RFC was just approved, and it's going to be part of XCM v5. So it's going to be part of the next SDK release, which is basically the December stable release, and it is planned to be live on chain, at least on the system chains, the XCM v5 in January, February sometime, basically
Right.
after the December release.
Maybe we're talking about a different thing because this one was in the runtime 1.3.3 list of released things.
Can you say the title again? I got confused then.
Okay, it's PR 407, allow signed origins to send arbitrary XCMs.
Okay. Yeah, sorry. Yeah.
Basically, I can submit an XCM to Asset Hub and it does something like it sends a message to another chain.
Yes. So basically, XCM is this, so it's meant to be cross-chain language. During its development, it was kind of bound in terms of who could send it, who could execute it, who could generate it. So, because we wanted to start slow, start safe, make sure we do all the audits, make sure we get it battle tested. But after, I think it's been a couple of years now since it's working on multiple chains. Now we basically kind of removed all the guardrails, like the paranoid ones, right? Not the necessary ones. And now we're allowing system chains and encouraging the ecosystem to do the same, and allowing basically execution of arbitrary XCM. So basically any XCM that you write, you're allowed to execute on chain. Obviously, there are security checks and sanity checks and other stuff that will make that XCM fail if you try to do weird stuff, right? But we are pretty confident we have all those in place now, and it's safe to basically allow executing arbitrary XCMs. And I think that was included in 1.3.0, and then this was another piece of the same, let's say, story, which is allowing to send an arbitrary XCM to another chain to be executed on another chain. So yeah, like you say, a simple scenario, or the basic scenario of this is Adrian, with my signed account on Asset Hub, can send an XCM with valid XCM on Asset Hub, sign it on Asset Hub, and say, on collectives, do this, and it will do something on collectives using my sovereign account or whatever.
Okay, super interesting. So it would also make it simpler for wallets to do one activity on multiple chains, no?
Yes. It could. I don't expect. So for wallets, usually you have an action that you usually take on this chain, and then some other action on some other chain. So usually the flow is using execute. So you execute something here, and part of that program is also sending or like doing something on another chain. So I don't know how big is the pool of use cases where a wallet would simply send, but there are obviously some stuff that you can build, and that this will allow it. Yeah.
All right. Cool.
So it's not a very sexy thing on its own, but it's part of this bigger story. And yeah, when we reach the full vision, I think it will be a very powerful thing where we have a lot of off-chain tools and libraries and stuff that expose all of these useful actions, intents, or stuff that you want to do or happen. And then with this entry points on the chains, they can just be run, right? And we don't have to depend so much on the on-chain logic. And you can see as when we try to change something on-chain, it's like a slow iteration. We want this, okay, we have to wait a few months, and then some other chain has to do it and wait a few months. So I expect this will, in the long term, will allow us to be like a really fast ecosystem in terms of iterating and innovating.
Yeah, I'm really looking forward to XCM season, because right now I see all these pieces coming together. Adrian, while we have you here, there was another thing, Asset Hub, allow Polkadot, Kusama, and Ethereum assets across the Polkadot Kusama bridge. So this is live now. So is it live on both sides of the bridge?
I honestly haven't checked. I think it's just updated today. I haven't checked if like all of them updated. But if they did, then yes. It's live. I don't think there's any. I'm pretty sure there's no tool UI wallet that would actually allow you to do it today. But now, from like starting now, someone can build it, or people can start playing with it even in Polkadot.js or something. But the basically what this allows, or what this does, is it basically adds support for moving any asset across the Polkadot Kusama bridge between the asset hubs. And even more than that, it allows bridging into Kusama the already bridged assets from Ethereum. So sort of double bridging. Basically, you just bridge in Kusama the stuff that you bridged in through Snowfork, the Snowbridge. So yeah, next, let's say, items on the to-do list is to register some of these assets on Kusama Asset Hub. So for example, wrapped ETH, and maybe other stuff that we might find useful or cool to have on Kusama. Yeah, unfortunately, I don't have the time to do that. I have it on a very long to-do list, but it's kind of way behind. So yeah, anybody else that feels interested in playing with it, be my guest.
All right. Okay. Thank you, Adrian. Yeah. Last thing I wanted to share, what I see on 1.3.3 is make the current inflation formula adjustable. So I think this comes just in time. I think it's released on Kusama right now. I'm not sure if it's on Polkadot, but this comes just in time for the discussion that concluded in Polkadot OpenDev, led by Jonas Gelein, to basically find a new value for the Polkadot inflation in the future. So I think this was just coming in time. All right. I would suggest we move on. And because it was working very well last time, I want to do this again and basically ask into the room, what is everyone working on right now, right? So if you have anything of interest where you think others should know about, or it would be interesting for the general audience, that would be a great time. Like if you have any specific project, we haven't talked about it in a while or something, come forward and share it a little bit. Else I'm just gonna call Basti.
That's a boring one. Is my microphone okay? Or
yeah, it works fine.
Okay, perfect. Yes. I'm working on this, like everyone wants 500 milliseconds. I'm working on that. While working on that, you realize that there's a lot of stuff which makes it more complicated, but yeah. So one of the things, for example, if you want to go like down to like how this 500 millisecond thing is working, like you basically like you take your 2 seconds block and divide it by 12, and then you have like 12 500 millisecond blocks, all of them put together into one big block that goes into the relay chain, and like the relay chain, Polkadot or Kusama, it doesn't even know that there are like multiple blocks in it. From like the relay chain point, it's like transparent. I mean, as I showed it that works, but the problem is now, like, if you go into details, because, like, for example, if you have, like, as I said, like, you need to divide a resource, like, normally you have, like, 2 seconds that you can use for execution and 5 megabytes for the proof. So you need to divide these resources by 12, which brings, like, problems. For example, if you want to do a runtime upgrade, then you only have, like, it's like a little bit less than 500 kilobytes, 400, whatever is like 400, whatever kilobyte is like the limit you have then for a block, which is probably not enough for most of the chains. So like that would be a problem. So there we will need to have like some kind of solution that you can like dynamically like change the block time a little bit. So like instead of having like 500 milliseconds, if you want to do like a runtime upgrade, okay, then you maybe say, okay, for this time I'm just doing like one block that takes like 2 seconds. It takes the entire POB size, something like that. It's only a rough idea right now. Yeah. I mean, like I'm doing the preparations there now, and yeah, you wanted to ask something?
Okay, right. So supporting chains with like bigger upgrades or like process more stuff during an upgrade also would profit from that, right?
Sorry, what again? What you said?
You have a runtime upgrade for a chain, and then it basically profits from having more, being able to process it.
No, yeah, the problem is like that the runtime upgrade needs more resources than like, especially like the POV size than like what you would normally have for your 500 milliseconds block.
Yeah.
Because like you need to divide like it's not that you get like 12 seconds, 2 seconds, 2 seconds per, which doesn't make any sense at all. But yeah, you need to divide your resource a little bit. I mean, like if you then go to elastic scaling, what you could do is like we do this kind of, we have like actually like 3, for example, you could have like 3 cores, then you would have like actually 500 milliseconds per block, and would have like 5 divided by 4, whatever that is now, 1.1 something with 1.25, 1 megabyte and 250 kilobyte of POB size. So like, yeah, there are tricks you can do in the end. But I mean, like the first thing we want to achieve is that you have like faster feedback, because like people like faster feedback. You click a button and don't wait like 6 seconds or whatever to get like, hey, it was included. That's the state changes. Yeah. All this magic happening.
Yeah, it's always interesting when you consider like the original problems of blockchain scalability, and now it's coming to this like delicate problems of like how can I process a bigger runtime upgrade, and we're going into this direction. I would like to go to the topic of Jam, and maybe because I see that we're having Gavin with us today. So Gavin, could you give us a little bit of an update of what's happening with Jam right now? And maybe I have some specific questions later.
Sure. So the main point of news on Jam is that the grey paper got an important alteration, and 0.4 of the grey paper was merged with that important alteration, called ordered accumulation, which essentially means that Jam's basic sort of atom of work, you might vaguely call a Jam's equivalent of a transaction, although the block doesn't really have transactions, so it doesn't map exactly onto it, but it's the sort of user authorable piece of data that informs Jam what work is needed to be done. It's called a work package. These can now, when they work their way through Jam into an on-chain ramification, so into code that has to be run on chain that eventually alters the chain state. In Jam referred to as accumulation, and the A of Jam. This up until this alteration, there was no ordering implied for this accumulation. Basically, if you had 2 work packages, you couldn't have a strong dependency between those work packages in terms of when they were accumulated. And the assumption was that the accumulation code would have to look after that by sort of buffering if a work package needed to sort of have effects that took place after an earlier work package, you'd have to look after that in the actual accumulation code and buffer the sort of implications until the earlier work package arrived. Now this is this has a very particular use case, and that's for parachains. Parachains will typically have some ordering between blocks. So I mean, they are like, unless it's like literally like sort of a fork, in which case you might not care so much about the ordering. But in general, parachains will want to have the blocks that they want finalized being accumulated in order, right? And this is already something which, you know, the Polkadot relay chain sort of necessitates. But it's not something that the model that Jam provides or provided necessitated. It's with Jam being more general, more abstract. And this ordered accumulation allows it to happen as part of the Jam protocol without therefore necessitating some additional logic in the accumulation stage to basically make sure that the blocks are actually accumulated in order, and that you don't like finalize a later block before an earlier block has come in. There is a second important use case, which is actually the reason that it was done, because the second use case, there is no workaround. And this is that, as I've sort of pointed out in Jam lectures, Jam allows for this, like what I've called a distributed decentralized data lake. So this like huge amount of data to be drawn upon by work packages, and sort of mutated and then fed back out into the data lake to be drawn on again in some work packages at a later stage, right? So this sort of turns Jam into a coherent machine rather than a bunch of shards that can't really talk to each other. And it's what makes Jam what I've called mostly coherent or semi-coherent, as opposed to the model of the Polkadot relay, the model that Ethereum is basically aiming towards, and the model that any of the other chains that are attempting to scale in a sensible fashion are gravitating towards. So Jam's actually sort of moving beyond this model and like actually being quote unquote mostly coherent. But the problem is that if you suppose you have two work packages, one that happens at time t and block at time t, one that happens at time t+1. And that first work package does some work and outputs some data into the data lake, and the one at time t+1 actually wants to take the results of that and do something else with it. So basically you're looking for, you know, high capacity sequential computation. There's a little bit of an issue because the block at time t+1 needs to reference the output of the block of time t, and given that Jam is pipelined, again for efficiency purposes and to make everything asynchronous and allow us to get through a lot more computation, a lot more data. There's no obvious cryptographic commitment that can be made to the output data of time of the block at time t, because of course you don't know what the output is of the block necessarily. You don't necessarily know the output, the block of what the output of the block of time t is at time t+1. So you can't make a commitment to the data directly. You have to sort of make a commitment to the work package, the thing that's like the recipe for generating it. And essentially, in order to, you know, it's possible to build a mapping of like those work packages or the hashes of them, which is a cryptographic commitment to the recipe, and build a mapping of that to actually what the data ended up being, the output data ended up being, the cryptographic commitment to the output data. But in order to check that cryptographic commitment is valid, you need to basically have the accumulation happen in order. And so this use case of basically being able to use the distributed data lake as a data repository for computation that happens between blocks. This is necessary. Ordered accumulation is necessary for this. So yeah, that took a little while to get through. It's a fairly substantial pull request, and it's the last fairly substantial pull request I expect to make to the core protocol before version 1. So that's sort of good. And there's a few other things now waiting to be done for 0.5 of the grey paper. They are in the repo as issues. I think I even have a milestone set up now for 0.5. Most of them are fairly small changes. Sort of tweaks, adding an extra field here, altering an order of 2 operations there. There's really not too much of significance to describe, and they're coming about basically as we prototype the full protocol, and we were starting to realize, well, actually, if we put this bit of data in here, then it means we don't have to, it's going to be way more performant, it's going to be way simpler to implement, or whatever else. Probably the most interesting thing coming up is the 64, well, interesting for teams building on, or that would be building on Jam, is the 64-bit PVM. So at the moment, the PVM, the Polka virtual machine, is 32-bit. It's based on a 32-bit RISC-V instruction set. This is going to be switched out to a 64-bit PVM, which should make quite a few operations more optimal on 64-bit hardware. It also allows us to get more data in and out of things like host calls, which is pretty helpful. It basically doubles the number of registers that we have to play with. So yeah, that should be good. And we are moving quite a lot. Was really sort of now formalizing and iterating on the inner PVM formalization, which is going to be crucial for implementing anything useful in Jam, in particular parachains, the PVF, the validation function, the thing that the relay chain does currently to check off chain, to check that the state transition is legit, and also this is going to be very important for doing our initial experimentation into the direction of core play. So basically, actor model system running within Jam. Now, we're not going to implement core play directly. That would be a bit too much work. What we're going to do is start implementing a suspend resume computation model on Jam. So basically something that allows us to compile a regular executable, like just basically take, I don't know, any sort of thing from like a C++ programming manual, or like maybe even like a really substantial piece of code, like CLI. Obviously, it's not like blockchains don't have any means of really having any graphical interaction, but yeah, something fairly regular in terms of programming, and retarget it so it executes within Jam, and try to prove the concept of having a near native level execution environment, but that's actually on chain, and uses Jam, like uses a sort of scheduler to schedule itself between Jam blocks, and like suspends and resumes and collects data from the distributed data lake and puts it back out when it's done with all of this stuff, actually making actors work. This is the thing that we'll be moving towards once we have gotten the PVM into gotten the inner PVM into some useful state. In terms of Polka Jam itself, the parity internal implementation, it's moving along. The on-chain logic is almost in line with 0.4. I've got a pull request I was working on last week. The rest of the team is mostly working on the off-chain stuff. So networking protocol is being finalized now, the first version, this like jam simple networking protocol. And we have a document detailing this that's been passed around to the teams. So we should be able to, by the end of the year, be sort of having some sort of interoperability between independent implementations, which is pretty exciting. And other than that, we're sort of making headway on getting the availability, the guaranteeing aspects, and also beginning on the audit, the auditing protocol element of auditing. So this is all sort of underway. So essentially, milestone 2, the bits of milestone 2. With a general hope that we will have something sensible working by the end of the year.
All right, thank you, Gavin. I have 2 questions. One is, from my perspective, a little bit technical, and the other one is very practical. So initially you talked about basically how to order different work packages. Now, when we talk about the coherency part and semi-coherency, it means there will need to be some kind of sequencer that, for example, allows different parachains to be sequenced together if they want to have some kind of composability. So is this already part of a roadmap, or is someone building this? Like, am I understanding this correctly, or is this a thing for the future?
No, so the sequencing parachains together is not something that we've embarked on yet, to the best of my knowledge. If we did, it would be just as doable. I mean, it's really almost entirely would be in Cumulus, not on the chain level, on the relay chain or jam chain level. There would probably be maybe some element on the jam chain level just to make sure that co-sequenced packages were finalized together, but that's about it. Relatively trivial. The problem with co-sequencing is that you have to basically have 2 full nodes that work very tightly together in order to execute the transactions that are cross-chain at the same time on both blocks. And this is sort of fine, but it doesn't scale, right? Because the problem is that if you have like 400 blockchains all wanting to be co-sequenced, then you have to have 400 full nodes all trying to work out what like all in the same basic process, all contained in the same block author, all trying to work out how to make transactions that sort of go across the chains in the most optimal fashion. So it's sort of is a bit of a band-aid for where you have shards and you want to do this sort of synchronous composability, but you across maybe a couple of high value chains, and you can use co-sequencing for this, and you probably get some value out of it. But it's like it's pretty questionable the degree to which it truly scales. I would say maybe get to 3 chains being co-sequenced, but it seems hard to imagine having hundreds of chains being co-sequenced. Of course, if you're stuck in the sharded mindset where you've got like totally different projects that are pushing their own shard, and you really want to solve you really want to provide some degree of synchronous composability, then you don't really have that many options, and this is basically what you just have to do. But it's if you're designing it from the ground up, it's not really, I mean, it's an incremental improvement at best. And this is why we're doing core play, right? Because core play is specifically designed so that you don't have sharded state. The state is shared across jam, and you can pull bits of it and compose it together as you need, and make those that synchronous composability on a much more agile fashion. So if you want this smart contract from that chain and that smart contract from the other chain to compose together, but then separately and in parallel, the same, another smart contract from the first chain, another smart contract from the second chain to synchronously compose together. That's not possible with using co-scheduling. Like you can only compose on the very, very coarse-grained blockchain level, not on the much finer grained, much more agile sort of smart contract level. CorePlay allows it on the much more agile smart contract level. And what this eventually gives the developer experience from this is one that's much more in line with what they would expect working on a regular sort of smart contract platform, where basically everything can compose with everything else for not such a great cost. As opposed to, if you want to compose two things that are on different chains, you have to basically make those chains be co-scheduled, and as such quite possibly prevent them from being co-scheduled with other chains. And therefore you kind of end up with chains fighting each other for being co-scheduled, with some, bell of the ball chain that has some smart contract that everyone wants to use. Yeah, so no, as far as I'm aware, no plans for pulling chains together and having synchronous composability on a sort of pairwise basis. But I mean, Cumulus is pretty. Cumulus would be where you would probably want to do that. And I mean, I know that there are synchronous composition. There are sort of what would you call it? Co-block authoring services out there, particularly in Ethereum, that would, maybe they would be good to sort of be doing it for as a service that could be maybe accessible to Cumulus. I don't know, but anyway, it's not really the focus of Jam.
All right. Yeah, this puts it in a lot better context that makes sense. So yeah, it's nice to learn to get a better understanding of Jam every month. Okay, I see one question here. What's the status in terms of CorePlay and designing it, or in which phase is CorePlay right now in relation to those other pieces?
Pure ideation.
Ideation. All right.
So we have an idea, a very rough idea about how it will work, and the components of Jam are being designed in such a way that they facilitate this kind of thing. We're not at the stage of having empirical analysis to actually see how fast what it is that we want to do in CorePlay could be done. And that I would expect will start early next year, when we have a useful platform on which we can prototype. And as I said, it's not that we're going to be prototyping the whole of CorePlay immediately. We're going to start with the sort of elements that are totally reliant on Jam. There's basically, CorePlay is sort of two halves of thing, right? It's two halves. It's like one element is the bit that uses Jam directly. So it's the bit that, like, having authored a work package, it's the service that sits on Jam. That's a good way of putting it. So it's the service that sits on Jam, and the CorePlay service, and it sort of takes work packages that are meant for CorePlay, or work items, and then it runs through them, and it maintains the actor's state and does anything that the actors want to be done, like send XCM or interact with other actors or any of this stuff. So that's the sort of you might call that sort of the CorePlay runtime or something. And then separately, there is the CorePlay scheduler, and that's the thing that does all of this difficult co-scheduling stuff, like pulling together different, working out how to partition actors, and then pulling them together, working out what the most valuable data that they can be fed is, working out what the most valuable sort of means of scheduling them that they can be. This is basically a huge constraint optimization problem, and it's the bit that we have sort of. It's not something that we're expecting is going to. Let me turn this down a bit. It's not something that we expect to it's not something I expect to sort of solve on day one. It's probably going to be that we start with something that's not super optimal, but will do roughly the right thing, and then incrementally make it more and more optimized. And inevitably, there's going to be a trade-off about, like, centralization and optimization. Like it's when you're doing these big constraint optimization things, essentially the more that you keep it to be the same block author, the work package builder, the more that you keep it to be like basically the less that you rotate this partitioning agent around, the more optimal the partitioning will be, unless they go rogue and start just, I don't know, doing the wrong thing. So you kind of want it. There's going to be some balance between centralization and performance, but this isn't necessarily a decision that needs to be made and fixed. Like, part of the sort of core play plan is that there will be different co-scheduling or different sort of partitioning and co-scheduling guilds, where actors will join the guild, and that will basically partition them. And if they don't like what the guild is doing, they're free to sort of quit the guild and go join some other guild, with the caveat that they won't have access. They'll only have access to the other actors that are in that guild, or at least co-scheduling access to other actors that are in the guild, not in actors that are in different guilds. So we got, as I say, it's at this stage there's like clear ideas. I would say it's like in a sketchy white paper stage right now. Like, we have a pretty good idea of the design direction, but it has not yet entered the prototype stage.
All right. Interesting. Yeah, it requires a new way of thinking about this. Okay, and then I got a question. So what's the status on the ChanToast, the basically the supercluster that is used for testing?
It's been built. We have pictures of assembly lines. I can maybe post one of them. How do I do this? I do this, and then I download, and then I now can I share my screen somehow? Share screen. Oh, can I just put a picture up? No, I have to share it.
You can. What you could do is you could send it to Jay on Element, and then he will present it on screen.
Okay, I'll do that. Right, Jay on Element. What's that Element handle? No, I got it. All good. I guessed.
Some Jay is going to receive it now. Yeah, so I guess after you've sent it, the viewers on screen will be able to see it, and for the others, maybe we have to look at it afterwards. All right. So the assembly line means the line, like where the individual machines are being assembled, and then later on they go into a.
Yeah, so the machines are being assembled, I think, in Taiwan, and then they'll be sent to Lisbon. Now, Portugal's import apparatus is pretty questionable. So it's actually taken quite a long time to get to the point where we can actually import anything. But I believe we are, as of the 1st of November, we have all of the process set up so the machines can actually arrive. So our expectation is that the first lot of machines, I think it's about 20, will be online around mid-November, probably in the second week of November. And then with the rest of the phase one of the toaster being completed by the end of the year. and ready for use. So that's actually works out quite well, because I don't think we're really at the stage that right now that we will be able to use it, but we are approaching that, and probably will be there in the next month or so. So yeah, it's pretty well, working out pretty well.
Maybe we're heading up for a good Christmas present. All right. Yeah. Okay. I think we can close down the jam topic, except anyone else is having specific questions. And if not, I heard that the jam tour documentary is coming up. It's the one that was done by Key Pictures, and it will be released on Ecosystemarium on November 9th. November 9th. That's the first day of Sub-Zero. So I think it's a great day to get the check it out on Ecosystemarium. When is this? This is like 3 weeks or so. Yeah, 3.5 weeks. Still too much time to wait. All right, but I'm looking forward to this. Okay, I think we can close down the jam topic. I guess Joe, is Joe already on the call? Not yet. I would like to ask about Plaza a little bit. But then how about we move on to, I don't know, Andre, is there any news on Snowbridge that is relevant for people here to hear, or any other parts of XCM version 5 or so?
I think you met Adrian. Yeah, I saw that it's under in the document as well. Yeah. So there's many things in flight. I'll go through the ones that maybe you've heard of before, but now they're live with the latest runtime upgrades, which is the fee reduction for Polkadot XOMA Bridge. We are targeting a 10x fee reduction, and in practice, it's like 25x fee reduction in terms of what user needs to pay for asset transfer. So that's live now. So it should really be a better UX now. Then moving on to XCM general, we have fee estimation supported for these XCMs that span multiple chains. There's dry run APIs and XCM estimate fees APIs. Runtime APIs that off-chain components can basically use. These are already integrated in all the system chains basically, and they're also available for the ecosystem to integrate. And I've been talking to some parachains that have already started on it. The other cool thing that's out, but actually I don't think that's not integrated yet in the system chains. It's coming up with the next release, but it's out in the SDK and released, which is ability on XCM to auto swap, to pay XCM fees using any asset if the chain has some asset swapping mechanism configured. On asset hubs, that's pallet conversion. On hydration, it could be the Omni pool. On Moonbeam, maybe they want to use some DEX smart contract like StellaSwap or whatever. But the point is, if the chain has some swapping mechanism, they can plug it in the XCM executor, and that will allow basically paying XCM fees in any asset that is basically swappable for the native one normally used for paying fees. So this should be like a huge UX improvement. All of these are possible now. You won't see them yet in UIs and in the wild, right, live, but hopefully soon. And then on stuff that is going to happen in the future, so to speak, upcoming stuff, we have on XCM v5 a number of RFCs that have been approved, merged, and now we're implementing them. Again, better UX around fees. Basically, we want to consolidate and control all the XCM fees, so you don't have separate execution fees, transport fees, or actually, they still are separate, but at the XCM language, you can control how much fees you're willing to pay in a consolidated way, and this applies to like the general purpose execution fees and transport fees, but can also apply to maybe some chain specific fees. For example, if you have some EVM running and you want to call something through XCM, you can plug in some sort of gas charging mechanism that can also be basically connected to this XCM fees mechanism. So yeah, overall, we want to have this more consolidated, unified UX experience for handling fees over XCM, right? And try to capture as many use cases as possible. The other thing is, for a lack of a better word, do you have questions so far? So
no, only after you.
Yeah, sorry. So lack of a better description is like complex asset transfer support. Basically, just have the language provide a way in which you can write a more complicated program that transfers assets across multiple hops and uses multiple assets with multiple, let's say, transfer properties. Some of them need to be teleported, some of them need to be reserve transferred, and yeah, up until XCM v5, there's no instructions or combination of instructions that would allow you to do that. XCM v5 will have that. And then the other thing is something I call empowered cross-chain origins, which is a collection of things, I guess. Again, trying to make across the ecosystem XCM more useful, more powerful, and unify a bit this origin concept in XCM. So basically, one of the things is consolidating and aligning location to account derivation. So basically, every location has a sovereign account or a derived account on other chains. There are some, stuff. There's some code that derives this account, and we've aligned all of this throughout the system chains. And I am in contact or in communication with partners that haven't moved to the latest or this complete definition. But the idea, the end result would be the same location would have the same derived account on any other chain, right? So it would definitely help with like UX and understanding or better, easier use, I guess, and understanding of the ecosystem. The other one is goes a bit hand in hand with this, which is support permissionless origin aliases across chain. So right now, XCM contains a mechanism or has support for aliasing into another origin, or saying, I am me, Adrian, on Asset Hub, but when I want to do something on collectives, don't use my derived account, but use my actual collectives Adrian account, right? We were just missing the mechanism to allow a permissionless way for people to basically fine-tune and control these relationships, right? So if I want to be able to support that, I'll just go on this other chain on collectives and say, my account that I'm signing now, Adrian, I want it to be also controllable by this other location, Adrian on Asset Hub, right? And once we have this, then new UX nice things can happen where you can actually sign a single thing on one chain, right? Do a single signature on one chain, but maybe control your same signed account, right? Same actual public key account on multiple chains. That's like a base thing you can build, which should be useful, but obviously the world is your oyster. A lot of other things can be built with this. And the last thing in this like empowered cross-chain origins bundle would be this RFC that I mistakenly thought we were talking about at the beginning of the meeting, which is allowing these multi-hop asset transfers to preserve the original origin so that you can do in a single program more complicated stuff like transfer some assets, for paying some fees, and then actually also transacting in the same program, or like doing something else that requires the origin, which was not possible before because any asset transfer would previously clear the original origin. Yeah, but all of this sounds cool and powerful. We're still some way before we see them live. So they should be released in December in the SDK, hopefully in the system chains like January, February. Maybe they are powerful enough or like attractive enough that parachains actually integrate XCMP5 to get all of these new features in the first half of 2025. And then by the end of 2025, maybe we will see some actual nice tools, dApps, UX, UIs, and stuff that make use of all of these powerful new things.
Wow, that's a lot. That's a lot. Quite nice. Thank you, Adrian.
We have this roadmap that we created. I don't know, I'll probably put it in the forum or somewhere. It's very fresh. Probably still needs some fine tuning. But try to put things up in this kind of epics things, and hopefully have tighter, let's say, communication with the ecosystem on which of them are more important, more impactful. Maybe we're missing stuff or not thinking about things that are really important or impactful. So yeah, any fellows who are interested in the topic, also take a look here, and then I'll try to get more of the ecosystem involved as well.
All right, thank you, Adrian. I have a question. I'm not sure, maybe you know who's the right person to ask this. When it comes to the topic of reading states from other parachains, so for example, Brian Chen was working on XCQ. Also, Sheyun is talking about having this available in ICMP. And I'm not sure if it relates in any way to XCMP, but let's focus on state reads first. Is this something that Brian is still working on, or how does it relate to the overall picture here?
So this is conceptually similar to XCM, but it's like for querying rather than execute, or like passive reading data rather than mutating actions. Yeah, as far as I know, Brian is still working on this, or like Brian's team or someone that Brian oversees is still working on this. Don't they have like a bounty for it as well? I'm not sure. I haven't checked it in a while, but.
All right. What's your perspective on how relevant is this in the overall context of allowing blockchain interoperability?
I think this is very important. So this kind of ties into some other thing you had on the agenda, which is part of the Plaza thing, which is also called like the Polkadot facade, and something that you may have heard of on the forum and stuff as view functions, or some sort of intense interfaces, where basically the idea was to build some sort of Polkadot facade, right? That's the name, code name for it. That is, let's say, a layer of abstractions which expose Polkadot, let's say, state without actually going to this chain or that chain and looking in their storage, right? So it can be maybe some simple thing like the balances of some chain without having to check the storage. But it can be some more high-level thing like your balance on Polkadot overall, which unifies behind the scenes like the balance on all the chains, and you just have some API, which is what's this account balance in the Polkadot ecosystem, right? And there's like a lot of ideas or a lot of things, but all of the direction is like trying to unify this Polkadot ecosystem from this sharded, islands, each doing their own thing and their own language and their own interfaces, into building things that allow it to talk to it as a whole. And XCQ is definitely it's definitely very well aligned with this, and it's an important part of it. So yeah, I expect we should be investing and increasing the priority of this, I guess. Because XCQ would then allow you to build this kind of stuff as a generic query program that can work on all of the chains, right?
All right. Okay. Thank you. Yeah, I will also ask Brian for any news. And in terms of ISMP, I was hearing that Bifrost is starting to adopt it, also POP. So I'm also curious to see what kind of what comes out of those experiments. All right. Thank you, Adrian. Yeah, I want to jump to async backing. I'm not sure whom to call here. What I was seeing is that on Kusama, it's now basically there was this referendum on to set the maximum candidate depth to 6. So this essentially would allow free cores to be used. So basically for the MVP of no, not for them. I think this is in relation to elastic scaling and async backing. I'm not sure. Maybe someone can help me understand this. So for async backing, I saw this proposal of set max candidate depth to 6. Yeah, and in the proposal it says this is needed for elastic scaling. So it seems like on Kusama there is now this rollout happening of elastic scaling, and this is playing together now. So are we going to see some kind of test parachain run on Kusama, or is it basically like, why is it rolled out on Kusama now? Is there like an actual test case?
Yes, we want to do some testing on Kusama with using elastic scaling and workhorse. That's like, it will happen quite soon, like next month. Yeah, it's part of the stammering project. But we won't gonna change those parameters on Polkadot like that. It's we're gonna deprecate asynchronous backing parameters before launching elastic scaling on Polkadot.
So, but are you gonna have a test chain for elastic scaling on Kusama?
Yes, we're gonna have a test chain. It will be like a test parachain, and we're gonna do some like STPS tests to see how many transactions we can push across many.
It's not going to happen like in the past that you need to register a system chain. You can just pop in a chain by core or by some core time and then run it. Is this the idea?
Yeah, these details are a bit fuzzy now, but yeah, it will be based on like core time, obviously.
Yeah.
The details are under like they're being established right now, so it's not clear at this point. More news to come in the future.
No, but this is excellent. So you're basically eating your own dog food. You're figuring it out as you go. I mean,
yes, exactly.
If you just look back, I don't know. It was 3 years ago, but the first parachain that launched, it was like this shell parachain, and then it had to go for a runtime upgrade to become. I think this was Asset Hub back then, right? And now you just say we're gonna launch it with core time. So this is like so much has happened in this last 3 years.
Yeah, it should be easier. I expect it to be easier than before. Let's see.
Okay, perfect. Yeah, Andre, while we have you on, is there any news on elastic scaling? Is this like your main thing right now to get this rolled out and figure it out?
Yes, this is true. So the current target, like starting from a high level, the current target for like releasing all of the code changes is the end of this year. But we're not gonna actually launch it on Polkadot until like January or February. So a few other things need to happen, like the fellowship runtime upgrade should be enacted, which will contain all of the runtime changes. We also need to wait for validator nodes to be upgraded to support RFC 103, as well as the new like dynamic asynchronous backing parameters. And finally, like there will be a referendum to enable RFC 103 node feature bit, so the validators can the collators can actually use it. So there are 3 pieces. So it's RFC 103, It's deprecating asynchronous backing parameters and like the slot-based collator, which is already, as far as I know from Sebastian, is in good shape and should be going out of the experimental phase like in December, so it should be like available. And currently, like the implementation is going well. We have merged the new candidate receipt primitives and like the new, like the runtime changes for RFC 103. The node side implementation is like just a draft, but it's like it should be fully functional. And the next steps are like audits, like finishing the node side implementation and testing. So we're planning to start testing like end-to-end next week, mainly with ZombieNet. Then we move on to, as we merge those PRs, we move on to testnets. And like the one hard requirement you mentioned, like the asynchronous backing parameters, you want to deprecate those. And we're going to move from like this static configuration on the relay chain to some dynamically computed values based on the claim queue. So that means that like the max candidate depth will be determined by the amount of cores that you have assigned to a specific parachain. So yeah, this is actually required. Like the max candidate depth tells you how many blocks are you allowed to submit to the relay chain, like for a parachain. So this has implications. Like the higher the number, the more resources validators need to spend to keep track of all of these parachain blocks. So in the case of elastic scaling, we're actually accepting parachain blocks which are not connected to any other chain. So because you're validating them in parallel, so you only know like what chain is formed after you receive all of them. So like we need some sane bounds. So it wouldn't be okay to raise this max candidate depth to 6 or even more. It's just better to have it dynamically computed based on the actual assignments. And this piece of work will kind of start on it next week, and it will be a node side change only. But yeah, we do expect we do need all validators to kind of upgrade, or like most of them. Otherwise, like elastic scaling would not work so well if like the backing group made this like all validators will not accept all of the blocks. So yeah, I guess this is all of it. Any questions?
So to summarize, there is a lot of details you're learning right now, a lot of, going into the actual meat. And it means you already see the changes that are needed before rolling it out on Polkadot. Is this correct?
Yes, we have a plan with hopefully all of the changes. So in January, February, we should be able to launch it on Polkadot safely and securely.
All right. Thank you, Adrian.
Andre, thanks. It's not Adrian. Adrian is not Andre, so.
I'm sorry. Okay, so I mixed up both of you now, so it's equal now.
It's not the first time.
My apologies.
Somebody mixes up, yeah. Okay.
My apologies. Hopefully by next time I got it. Yeah, maybe the last thing in this trio is Agile Core Time, and yeah, the summary from last time is that Agile Core Time, it's rolled out. It's on Polkadot. Since we had our last call, 5 cores were sold on Polkadot. The first 5 cores. Very first core was sold for 69 DOT. And I think in total it was like 260, 270 dots that got burned already. So yeah, we can look into the future. And for this cycle, everything should be clear for the parachains. And then in the next cycle, is the first cycle where parachains should, the first parachain should actually renew the slots, or basically go into this core renewal. It's looking fine so far. The one note that I took from last time is that auto renew feature is in the works. Does someone have anything to say on that?
I think it has been merged. Yeah, it has been merged. So it should be part of the next release.
Yeah, it's in 2409, release 2024-09. So whenever we update it in the runtimes, it should be straight in.
Cool. Yeah, it was very interesting to have those discussions on Twitter, on X, because this actually raised a lot of people questions from people even outside from the Polkadot community, people were really interested. What does it mean? What is a core? What's the effect and so on? So these were very interesting discussions. Robert, Donald, since I have you here volunteering to speak, do you want to share a little bit of what you're doing at the moment? Maybe Robert?
Well, for core time, what we basically core sharing on Polkadot. We're working on finally enabling this. So this is pretty much done, and this is also part of the next release. Yeah. So you can actually like right now we have so many cores you don't really need it, so it's not crucial. But like to have the feature complete, we want to be able to have chains sharing a core. And there was one remaining issue. That's why we disabled it for launch. But yeah, we will have it enabled with the next release. And yeah, and then you can even share code, like have cheap code that you share, and then you're even cheaper. So yeah.
Right. So chains can become friends, share a core.
Exactly.
Interesting. You're putting way too many optimizations into Polkadot. It's all going way too fast.
Yeah. Yeah.
I think we also have Sergey on the call here, who is building Regionix, right?
Yeah, so we have the UI that supports Polkadot now. We also plan to deploy the parachain with the core time marketplace on Paseo, but yesterday I noticed one thing is missing on the core time chain, so it will take a bit more time.
All right, thank you, Sergey. Good. Yeah, maybe. I mean, Donald, I mentioned you before. Is there anything you want to share at the moment?
Yeah, so today with the upgrade to 1.3.3, we fixed a few things that were still not right in the state for core time. And so, yeah, that was like the final referendum for the launch of core time on Polkadot. There were just a few issues with the lease end dates, which a few people have picked up on in the state. So they're all fixed now. So that went as we expected. Yeah, and then next step, there are a few things to clean up in the code, like making this core time implementer palette, which is sort of partially done, but got deprioritized with all the other stuff going on. So yeah, that's sort of next step, and then thinking through these pricing considerations. Like it'll be really interesting to see how pricing goes on Polkadot, because the numbers we have from Kusama are kind of each month there was something different, whether it was a different model or more cores or different different market conditions. So it's going to be nice to have a few months on Polkadot where it's just the same conditions that we can compare. Because the first sale, obviously, like 69 dots, that isn't a random number. I think that was somebody going for the first core, and so yeah, we'll see which of these cores get assigned, if any, or whether it's going to be like Kusama, where people rushed to just be first, and then next month should be more like people actually want to use the cores, and like we've seen on Kusama, people discover different ways of kind of buying, and especially when we have secondary marketplaces, how the secondary markets affect the actual primary market prices, and then adding in the interlacing that Rob was talking about, like that adds another layer of unknown. So it'll just be really cool because there's nothing that we have like this to kind of reflect back on for historical data on these kind of pricing models for this kind of thing. So yeah, that's what I'm kind of looking forward to, and thinking through the next iterations of core time.
All right, thank you, Donald. Yeah, it's nice to have fans of Polkadot that are just willing to drop 69 dots to buy the first core. Just to write a little bit of history. Okay, yeah. I want to go into the next segment of our call, which is the topics that have been raised by some members of the collective. So I see that we have Pablo here, and I guess we also have Cisco here from Cisco. but it's hard for me to see on the screen. Let me check. Okay, I don't see it. Yeah, Francisco. Okay, I see you. Yeah, so maybe Francisco, can I call you first? And you wanted to talk about RFC 122, asset transfers can alias XCM origin on destination to original origin. I'm gonna post the link into the chat. And Francisco, you want to talk about this?
Yeah, so I put it there because I felt it was very important to talk about, and also because the voting hadn't concluded yet. Now it was done and it's been executed, but it's something already Adrian mentioned. It's something a lot of parachain teams have been wanting, which is to be able to retain the original origin when sending, for example, a reserve as a transfer from one parachain to another that you go through GitHub, for example, and to be able to preserve the origin. So then on the last hop, you can actually transact, which right now you can't because the origin is cleared. And yeah, I just added it there in case we didn't have time to talk about it. Also to get people to vote on it, it has already passed. So to let people know that in the future, if you go through Asset Hub, you will be able to retain the origin and still transact. So send your assets, your fees, and transact on the same message. No need to like pre-fund and then transact.
So what could the other chains do with that kind of information? They would be able to know who to call back if there is an issue, or what would they do?
You need an origin to be able to transact. You don't if you want to do things that only use assets, for example, making a swap. But if you do want to transact, so if you want to call any call or execute any call on the other chain, for example, Alice, now that we are allowing all this arbitrary execution and sending of messages, execute something on one chain, sends a message to another, taking some funds with her. And after the funds are reach the last hop, she can also execute some call on that chain on behalf of her account, like on behalf of the location parents and then Alice. The parents that are parachain, the origin parachain, and then Alice. Before you couldn't do that, you will need to do it in 2 steps. First, you send the money, and then you send another message where you actually transact, and that has caused a lot of problems, or many people have asked for it to be fixed. And now with this RFC that Adrian made, it will be possible in XCMV5. And once we get some buy-in, or it will become better if more people start using it.
All right, Francisco, and like, what's your ask for the fellows? Should they look into it? Are you looking for specific feedback?
Yeah, I put it there because I wanted to see more feedback. We've seen, I mean, the vote has already passed, but it would still be useful. But yeah, that happened after I put it on the agenda. So, but it's pretty much reading it and getting some feedback. Yeah.
All right, perfect. Yeah, we put the link into the chat, and yeah, you also put it into the fellowship chat. Good. If it's fine for you, we would be moving on. All right, thank you. Good. Then let's have Pablo on, and Pablo is bringing 2 RFCs. So the first one is RFC 100 and 17 Unbreak Collective.
Yes. From Brick Collective, there was initially an idea of a collective that could execute some instructions in the parasite that allow the collective to help a parachain team to unbrick a collective, which is help the parachain to start producing blocks again if for some reason the parachain stop producing blocks. There are many reasons that might cause this, but essentially some of them are related to configurations and on the runtime side. So the tools we already have for that are two. First is changing the runtime PBF, and the second one is changing the head that's on the relay chain side. Those tools essentially allow parachain teams to create some kind of time machine that can go backwards and make fix changes. This has to be precisely well thought in order to help parachain teams fix the runtime, but not make unwanted changes like changing the balance of the accounts if you go way back in time, for example. So with this in mind, and the fact that in order to do this today, you need to go through the governance on the root track, which is pretty expensive and very time expensive. This Unbreak collective was thought to be created. So basically, the RFC defines the scope of the collective, the responsibilities, which people can be member of them, how to add members, what are the procedures for creating it, and the tools needed in the Polkadot case. Some of them are actually implemented in a pull request that is open as a draft, not yet open for review, because I'm basically waiting to get more feedback in order to see if I need to make some changes on the setup on the Polkadot case end. And after that, the final step will be making the changes in the runtime's configuration to make sure this Unbreak collective happens. So I'm open for feedback. I would like to get as much feedback as possible, especially because this is really sensitive for some teams, and we would like to make this collective to be created in a way that it essentially is a source of trust for most of the community, and people are sure that they will work towards helping parachains be fixed and not altered in some unwanted ways. That's it.
All right, thank you. Anyone having any question on that? All right, then let's move on to the last bit here, which is RFC 121 iterable referenda tracks. So this one caught my attention, and I'm going to drop it into the chat here also. So it is also from you, Pablo.
Yeah, one of the things that are really interesting about the OpenGov mechanism is that you might is that you have these tracks that can be resolved onto different origins, and these origins can execute different actions with different permissions on the chain. And well, as of now, these are static on the Polkadot SDK, which means if you want to make a change on a track, maybe a change on the curve, or a change on which origin it relates to, this means you have to make a runtime upgrade. So this concept of creating dynamically configurable tracks is the thing that originated this concept of the iterable track. So basically, an iterable track is converting this static array into an iterator that can be called in a static manner as well. So under the hood, it uses a COW structure that helps preserving powers compatibility with the static defined arrays. So it doesn't create allocations unnecessarily on the runtime, but at the same time, it allows for creating an iterator, which is the mechanism that allows to add new tracks, modify tracks, etc. So that way, we're sure we can make we can create an impact, and it's not just for the main relay chain governance, but also it can help other use cases. For example, in Cribble we have we are actually currently using these iterable tracks because we have these communities, these DAOs that are defined through a palette called DAO communities, and this palette uses another helper palette called palette reference tracks, which is an implementation of the iterable track. So you can create tracks dynamically that are tied to those communities, and when you create a new community, you can create a new track for that community to create proposals on specifically that track and run with an origin of that community. Use the same benefits and the same system of OpenGov, but on those specific governance, local governance mechanisms. So it's really a great tool to have, not just for the relay chain governance itself, but also for other use cases, other things that developers might create as well. So again, looking forward to get as much feedback as possible. The pull request with the implementation is ready, and we're currently created an implementation that uses palette parameters. I remember it was called, to test it on the Polkadot SDK kitchen sink. But we would like also to push the existence of better suited, better configurable palette, like palette referendum tracks. So that's part of the RFC. So it's a proposal. If you think that will be an interesting addition to the RFC to exist on the SDK, that's an idea. If not, well, there are other ways to implement it. And that's it.
All right, thank you, Pablo. Any specific questions from the fellows here? All right. Good. Then we can move on. Thank you, Pablo. So Brian Chen asked me to let everyone know about this small announcement. So he he and his team made some progress on the Polkadot ecosystem tests. And basically they have the milestones 2 to 5 done now. So I'm posting this link in the chat for you. So from what I understand, this is an example of how to use a bot or how to trigger an action. So what Brian is asking is that people play around with the test suite and maybe write their own tests if they find it interesting. Yeah, so that was the announcement from Brian. And then I think the last thing I have today is a community question, and that is, what's the status with voting in nomination pools? I believe I have seen this on a previous release, but I'm not so sure. So voting in nomination pools, is there someone who can share something about this? Maybe someone who packaged a release recently and saw it? No. Too bad. I think we have it as a PR. Yeah, it would be nice to find the PR or the issue, because I remember reading some documentation already on it. Okay, so we have to.
Yeah, I think so. I think there's an issue for it. I saw it as well on the runtime repo already, and I think there was a PR somewhere about that. I think it is coming, but let me search for it. Yeah, enabling open. Okay, yeah, it depends on the stable 24.9 release. So like we need to upgrade the it requires the fellowship runtime needs to be upgraded to this SDK release, and yeah, I think then it can be integrated. It's like
So,
I can send it.
And the stable 09 version is coming. Because I also saw an issue to integrate the 07 version, so we're basically 2 versions behind right now.
Yes, but I think we will combine both versions into one.
Okay.
Which we should start in the near future. So I assume that 24.9 will be that will probably be 1.4. So probably the last release we see this year. Yeah, maybe minor releases, but from a major point of view.
Okay, so it's basically built. It just needs to be integrated, and so we have a path, and this looks like it's going to happen soon, right?
Yes.
All right, thank you, Bastian. Yeah, from the list of things that I see, this is fine right now. Only thing I miss is information on Plaza, but I guess we would have to rely on Joe for that. But other than that, I think we got a lot of stuff done today. Got through a lot of material and also could learn more about Jan. So yeah, I think we can close down the call at this point in time. Thank you everyone for participating again this time. And as always, there will be call notes. And if no other topic rises up right now, then I would say we close the call down here. And thank you. Goodbye, everyone.
Ciao, ciao.
Goodbye.
Bye.